Good morning, everybody. This is Kevin Renaud with Peerless. You see Dan Morgan there, Dave McKendry, Brian Isom of J-Flow Controls, and Greg Barrow. We're going to get this thing going, so we just wanted to say hi first, and we're going to turn our cameras off. Thanks again. Again, it's Brian Isom with J-Flow Controls to talk about actuation. This is a topic that we've been pretty excited to get to throughout the course of our e-learning presentation. So again, we have a great group today, a very large turnout, quite honestly. So we're thrilled to have you all with us. I apologize if you don't see a star on your location. They were coming in pretty hot and heavy this morning, so thanks again. Again, Peerless opened in 1914, General Mill Supply, downtown Buffalo, New York. Really well known back then as a General Mill Supply, wheelbarrows, shovels, aprons, serving the grain business, the aggregate. We've certainly evolved over the years. We are an ISO 9001:2015 company now, and we have become a trusted source for process components. We operate in 3 segments. We have our process group, that works with in the plant environment, working always in an effort to help our customers do things better, faster, safer, cheaper. We also have our Procore team, which works with our equipment builders, OEMs, and some more complex projects. Typically, a lot of projects that end up somewhere else overseas that require a high level of specification review and documentation. We also have our high temp fabrication group, where we do machine solid surfaces, scientific, laboratory, and a high temperature refractory type insulation. So again, Brian Isom, he's been with us before with J-Flow Controls to talk about General Ball Valves 101. He is back with us today. We have Dan Morgan, who you've seen, Greg Barrow, and me. And once again, you may remember from Brian last time, he told us that he is a golf and classic car enthusiast. There's the Golf, and you see the car, one of the cars he used to own. But when pressed, I wondered if I misheard that, and he's not a golf and classic kart enthusiast, because I believe I saw this on Google Maps in his parking spot. So on that, I know I'm running out of material here. So I'm going to turn it over to Dan Morgan, who's going to talk about the platform for today's meeting. Dan, take it away.
Yes, gladly. Thank you, Kevin. I'm just going to turn this presentation over to myself real quickly and just cover a couple of housekeeping items here. For those of you that may not have been with us before, I'll just give you a quick introduction of the control panel that you're seeing in front of you. So here's a quick shot at it. You can collapse the control panel with this orange arrow if you'd like to get it out of the way. Toggle in and out of full screen mode right here. You can raise your hand if you're having any trouble or whatnot, and I'll see that and I'll be able to reach out to you and ask how I can help. Changing around audio settings is done right here. Microphone and speaker inputs and outputs. So most importantly though, where we want you to pay attention to is the questions panel down at the bottom. So as Brian's going through his presentation, if there's anything at all that you have a question on, you want some more information on, some clarification, maybe an application that you have in mind that might be relevant, please do not hesitate to ask a question through that panel, and I will be keeping an eye on that and then finding moments to interject into Brian's presentation to make sure that we get those questions answered for you. So yes, please do not hesitate. Yeah, with that said, I think we're ready to turn this over to Brian and get us going.
Thank you very much. Oops, here, let me get my screen all taken care of here.
Yep,
can you
perfect.
see everything?
Absolutely.
Okay, great. Hey, thank you guys very much. I appreciate you guys letting me be a part of your ongoing training, and I hope we can go through this fairly easily and quickly today. I hope you learned something and you find it informative. And as always, we appreciate your guys' time for being here and making time to do this. Okay, all that said, we'll go through this real quick. This is to cover mostly actuation and automation. So if there's any time, as Dan mentioned, go ahead and ask a question and I'll go ahead and get this started. Oops. Can you see that okay?
Yes, we see the presentation now. You may need to click inside of the presentation in order to make sure you're in there to advance it, but
there we go.
There you go. Perfect.
Just a quick overview, besides technical difficulties. J-Flow Controls, we've been around for over 20 years. We have over 50 years in the valve industry from everyone that's here. We are headquartered here in Cincinnati, Ohio. We have offices in Los Angeles and Tulsa, as well as other offices around the world. One of the things that is nice about working here is that our products continue to develop and grow. So does our facility. So we have full automation facilities, inventory, and a very, very nice machine shop. So we are manufacturers of slab gates, globe valves, ball valves, control valves, electric actuators, and a whole slew of valves that you can see here. So just a quick overview of who we are. The overview on what we're going to talk about today would be rotary pneumatic actuators. That includes rack and pinion, the vane type, Scotch yoke, and diaphragm. So in that, we'll go through each section here and break it down a little bit more for the linear actuators, the rotary electrics, the linear electrics, and we even kind of threw in the gear operators and declutchable gear operators. So let's begin. So a few things to consider before you're putting together an automated valve, which is, a lot of this is elementary, but at the same time, it is something to remember and consider. Is there enough air supply available for the product that you're going to use? Is there electricity available? The fail position. Do you require a feedback verification, which we'll get into, which is a limit switch? Is it on-off control, modulating, and the type of valve to be automated? And that's typically specific to every industry. So we wouldn't necessarily put a carbon steel valve in a food application. So again, we would already pretty much have an idea of what we're going to be automating as soon as you let us know the application. So, and it was designed for the environment to hold up to whether it's cold, hot, wash down stations, all of those things to keep in mind. And is it the valve going to be designed for that application? So, and the process conditions. The pneumatic types. So we'll go through the pneumatic types. What you see there is typically the rack and pinions. Rack and pinions are very, very economical. They're compact in design. So here you'll see our limit switch that's above. This is our rack and pinion actuator. These are rack and pinion. This one happens to be our stainless steel. This is our extruded aluminum. And these pressures are up to 115 PSI. Any higher than that, we typically would go to a different style of actuator. We can go as low as 30 PSI. We'd simply take the cap off, remove the springs, and then we can operate these at a much, much lower pressure. And then, but we would have to also increase the size once we do that. So the Nemer mounting, which is on the other side of the actuator, Nemer was started years ago for standardization for solenoids and accessories to be mounted on the side of the actuator. So when you hear some people say Nemer, some people say Nemor, and we understand what you're saying when you say it. So Nemer is an actual acronym for, I can't speak German, so this is kind of a shortened, abbreviated version that everybody has standardized to for these solenoids. So they're a multi-spring. Some have a single spring. There are other manufacturers out there that use 2 springs, 1 spring, multi-springs. Ours is a multi-spring. And they're also, the one thing I didn't put on here is there's a 90-degree rotation and there's also a 180-degree rotation. And I should have noted that. The seals that are available, NBR, Buna, Viton, and silicone. Ours are standard with the silicone because we can cover probably 99% of all applications. And ours are rated up to 300 degrees Fahrenheit. So it makes a really, really nice actuator, and we standardize on one thing. The actuation type, spring return, if you want it to fail back into a certain position, or double acting, depending on what functions you need. for that actuator to do. So typical applications: on-off control, modulating control, dampeners, ball valves, plug valves, butterfly valves, even segmented valves. We've used these on segmented valves where we have a requirement of space issues. So that's a lot to consider as well. Here's an inside peek. You can kind of see the inner workings of the actuator springs. That's a multi-spring, and the pinion itself is turned. As soon as we put air, we push those pistons outward, and when the air is released, you see that the springs are actually forcing those pistons back into position. And typically, this is something that we look at is we include a safety factor. So if we have a valve, let's say, for example, that requires 100 inch-pounds, we will typically have a 30%, a 25 minimum to 30% safety factor that we are applying, and then to make sure that we have more than enough torque on the fail position to turn that valve back to its desired location, or fail position in this case. Scotch yokes. Continuing on with the pneumatic types. The Scotch yokes typically are used in the pipeline ESD type application for their high torques, larger valves. These are all used for a 90-degree rotation, and the same seals are available in these particular actuators. We do have a Namur mounting kit that we can put on there, but they're all ISO 5211, which means we can take just about any limit switch, positioner, and put that on there with ease. So some customers prefer a spring return, some customers prefer a double acting. Typically on an ESD type shutdown valve, they want a spring return, so they want to make sure that it does fail in that required position. And here's a quick example of the Scotch yoke. I'm going to cut away, and you will see the stems pushing one side to the other. We put air to the one side, and we collapse the spring. And then as soon as the air is removed, you'll see the spring takes over and pulls it back to where its original starting position. Now for a fail open, it rotates very similar. It just have a different fail position and a different rotation. So if you notice in the previous picture, it was rotating counterclockwise and then clockwise to open. And then this one, it is rotating clockwise and failing to the counterclockwise position. And the same is true when we have to set up segmented valves. So we have to pay attention to that fail position and rotation. Continuing on, spring diaphragm, rotary, 90-degree. There are several manufacturers out there. The Fisher has one, Jamesbury has one, Zurich has one. So looking at these 90-degree rotation, there's not a whole lot of rotary actuators that are diaphragm out there, and especially ones that are ISO 5211 mounting. So we can take a valve, direct mount it, there's no bracket coupling required. The nice thing about having a spring diaphragm actuator is it is very resilient to air supply moisture. And whereas the rack and pinion, typically in a air plant, or a plant, with air supply that has a lot of moisture in it, you'll tend to see some scarring. You'll see resistance and wear as the moisture has scarred and created all kinds of havoc on the inside of a rack and pinion actuator. Whereas a resilient actuator doesn't care about air, or water, moisture being on top of the diaphragm. It just keeps going. We use these typically for fine control on our segmented valves and our V-balls, butterfly valves, and the ease of maintenance is just to simply remove these 18 bolts and put the new diaphragm in and put the bolts right back. So maintenance is very, very simple. The guys like them, It's a quick, easy repair, and they're up and running again. And again, like I mentioned on these applications, the segmented valve, high performance butterfly valves, precision control. The pneumatic linear, the spring diaphragm linear, typically you'll see we put these obviously on our control valves, but we've had guys use them for dampeners, moving levers for low pressures when they don't have 80 or 100 pounds of air available. Sometimes a diaphragm actuator is something that they need just to move a rod or push something out. They have used these. I included it in this slide just to kind of show you that we have used it for other things. Same thing again, very easy to change the diaphragm in 2 O-rings that are typically here on a pressure to open. Next in the series is the vane actuators. Vane actuators, as customer preference typically, the brands, Kinatrol is a huge manufacturer of these. Crane makes one, we make one. They are double acting, very simple process where we have air going in one side to force the vane to the right, and then we put the air back to the right side and we force the air back. And this is one giant O-ring that is inside of here. It's a seal. I shouldn't say it's an O-ring. And they'll put a spring pack underneath these areas here to create a spring return actuator. So it has one moving part, very easy to maintain. Pick the clamshell, simply take it apart and put the repair kit in. And these are used a lot on dampeners, HVAC. I've seen them used in modulating and on-off control. So a lot of the accessories that we use typically will be, again, from the customer preference. What type of solenoid do you need? What type of voltage is required? What type of classification is required? Is it weatherproof? Is it explosion proof? Do you need Aussie bus, field bus, mod bus? Those things are available to put in, and they're in combination typically with the limit switch. So they incorporate them together, and they can use any type of bus system typically to meet that requirement. The solenoid valves, there are lower voltages. The ones that I had on here is 12 and 24 volt, 120 and 220. Those are most typical, so I just included those. The other accessories that we are using are positioners. We have 4 to 20. There are some 0 to 10. There's Hart and the field bus type positioners. We'll briefly talk about volume boosters. Lockup pilots are typically used in areas where the valve must remain in that position until the upset condition is restored or corrected. So, and then also including the compact filter regulator. Solenoids are pretty, self-explanatory a lot of times, but it's always good to review the types of solenoids and what they're used for. We're putting these directly to the side of the actuator with that Nemur mount that I was talking about. They've standardized to where you see these 2 holes. It's kind of hard to see in this one, where it is a standardization that they are putting on the side of these racket pinion actuators, and it creates a very simple, easy, standardized assembly, uniform type solenoids to use in the industry to make sure that we have provided everything the customer needs in the fail position, double acting, spring return, dual coil to shuttle back and forth. So there's a number of applications, and then you have the customers that are preference-wise. They want a regular standard 3-way 2-position line mount solenoid. And the things to consider, again, weatherproof, explosion proof. We can do bus networks, single and dual coil. Limit switches, we're trying to verify the valve position Typically, they're feeding that back to turn on a piece of equipment or for an alarm, something to verify that that has reached its 100% open or 100% closed position for the valve. And these are all calibrated and set once we put an assembly together. That way the customer doesn't have to sit and try to do that. So we try to get everything together prior to the customer receiving that. Valve positioners. The valve positioners, there are many that are out there. Our particular brand that we like to use is a company called Thyssen. Here's a VAC, and here's a Fisher Field View positioner. And depending on what you're going to be using a positioner for, whether you have a lot of moisture in the lines, some of these positioners do not like, they use a piezo crystal, and some use a different pilot technology, where ours, we take water and we spit it out. The biggest killer for a lot of these positioners is moisture in the lines. And positioners do not like to have water put in them. And our typical control signals that we are doing, it's typically a 4 to 20 milliamp. There are a 0 to 10 volt. And all we're trying to do is to make sure the valve moves 100% open or 100% closed within that 4 to 20 milliamp range. And again, we can do communication and maintenance functions that are used in a bus system or heart communication. Again, briefly, the volume boosters. A lot of times these are used. The example that we have down here at the bottom is a control valve. And typically what we're using these volume boosters for are larger volume cylinder actuators, whether it be rack and pinion or a Scotch Yoke. And the positioner has a very small orifice, and it's trying to fill a very large area. So what we do is we will add this volume booster into the supply side, and then we take the output from the positioner to this volume booster. And what happens is the orifices that are inside, I should say orifice, excuse me, inside of these volume boosters is 4 or 5 times the size of the orifice that's in the positioner. So we can take the output from the positioner directly to the top of this volume booster, and we take the air supply that's coming in, and we're basically quadrupling the volume that is allowed to go to the actuator. So that's the example that you see here. As we waited for a positioner to fill up a large volume cylinder, the controls would not react in time. So a volume booster is required to do that, to make the actuator move faster.
Hey, Brian.
Yeah.
We have a couple of questions that came in here on these accessories, so I figured now's a good time to cover those. Going back to limit switches, can you possibly comment on the reliability of a proximity type versus a cam and read switch type limit switch?
Yes. So the proximity switches have gotten better throughout the years, and I think I understand the question, because the proximity switches throughout the past have typically not been as reliable as a mechanical switch. The improvements that have been made over the years, at least in recent years, have increased greatly. And so we have customers where you cannot afford to have a limit switch that has a mechanical device where there's any chance of an explosion. So the proximity switches are used in that application where there are no moving parts. You're using that reed switch to rely and move and make that signal connection back. And it's typically on those areas where proximity is a must and they can't take any chances with an explosion versus a mechanical switch, you know. So I don't know if I'm answering the question correctly, but the proximity switches have increased in reliability in recent years versus the old ones that were made. Mechanical switches typically, again, are used only where it's safe. We know that it's going to be sealed. We know that it's going to be, you know, everything is intact, and it's a good environment where we know we can safely use a mechanical switch. Whereas proximity switch, we have to make sure that they do not have any kind of chance of an explosion or a spark or an arc. So.
Perfect. Actually, just to get some feedback that you did interpret that question accurately, and the answer was well received. So thanks for that.
You bet.
And going back one previous slide to solenoid valves, I believe it's the one previous to this. Is a solenoid valve absolutely required in order to control the actuator?
No. On solenoids, you're taking a pressure and allowing it to open and close. So wherever that air signal is required for an airtight application, or a pneumatic application, I should say, solenoids do that purpose. So you're taking a voltage to send it to open and close. But if you have a signal that's coming, let's say, from a controller of sorts, you don't necessarily have to have a solenoid. Now, a lot of companies will use a traditional three-way valve, or excuse me, three-way two-position solenoid, where they'll have supply coming in, and this is energized all the time. And in an upset condition, this allows to close and vent, and it puts the valve into the fail position. So there's a number of things to do, but I don't think you necessarily have to have a solenoid to make an actuator open and close, no.
Okay, great. Yeah, I'll let you know if there's any follow-up or anything else, but that's everything we got for now.
Okay, we're moving forward. One of the things that is required of us, because we are an ISO company, and you should expect this from anyone that you purchase a valve assembly from, is the things to consider is a QC checklist. We have to make sure that all of our assemblies are documented, and verification was used. So we have an assembler, as you see down here. This is an example of ours. Then we have it was checked by, that's our QC manager. So his job is to make sure that the assembly was done correctly as ordered. We go through the verification process. You'll see down here, there's a number of things that we do. We put the heat codes from the valves on there. That is a must anymore, just about, for anybody that is purchasing valves. The bolts, I had mentioned on bolts, especially if you're going to use the valve in a, say, an H2S type environment, and this gas is highly corrosive. So the bolts would be changed and noted here that we used a high grade, high tensile strength stainless steel bolt. It notes the fail position, it notes what actuator, it notes the ends and everything that's on here, extensions, anything that we were using, model numbers, and then they'll put the serial numbers typically down below for each one that is used. And this is kept on file. So if a customer requests it, we send a copy with it, but it is kept with that paperwork until, I believe it's 7 or 8 years. And then even then it's filed away. So it's always a good practice to have for us and for everybody else. We also typically will have an assembly drawing, which I didn't include here. So it kind of goes through the assembly process, making sure that everything is correct when it leaves here. Just a quick example there. And again, we were talking about the gear operators. This is a picture of our gear operator with a limit switch. Now that's something that's added recently to where a customer wanted to open and close a valve, but they wanted to have a limit switch feedback. So we did that for them. And then this one shows the declutchable. So the actuator with the limit switch and the valve is operating normally. And in the event of a upset, we lose air, they simply engage the clutch, open or close the valve, also known as a manual override. So even if it's in flowing condition, we can actually close this valve and make it do what we want it to do as long as we engage it. So the operator, this freeze flowly, operates easily and without any type of interference until the clutch is engaged. Then we can open or close this particular assembly. And here's some examples of some automated valves. Limit switch, just like we just showed in the previous slide. Limit switch, stainless steel actuator. These are just stands. I had someone ask me that one time, what are these? It's a high performance butterfly valve, and that's our stainless steel actuator that we put on that. And here's our control valve. We even put, you know, the other guy's positioners on because that's what a customer wanted, and that's fine. An automated three-way valve with just a plain actuator, and here we have an explosion-proof positioner with one of our rotary diaphragms on our segmented valve. We'll move on now. We'll get into the electrical actuators. You can see the examples here to the right, but typical applications, these are a multi-turn for like our gate valves, slab gates, globe even. Here is our globe control, and then our butterfly valves, ball valves, our smaller units, and here's a much smaller compact unit. These actuators are 90-degree rotation, multi-turn, and all the NEMA certifications that are required, on-off control to modulating control. The 0 to 10 volts is typically used in HVAC type area. 4 to 20 is a standard, and a fail-safe. So we'll get into these types of actuators in the coming slides, so it makes it a little bit easier.
Hey, Brian.
Yeah.
Real quick on this. You've mentioned the phrase segmented ball or segmented valve a few times. Can you maybe just elaborate on it or define that a little bit?
Sure.
For those of us that are unaware. Yeah.
Absolutely. So in a typical ball valve, if you're not familiar with the segmented, typical is a ball with a hole in it. Okay, that's just a full ball valve. On a segmented it's a half of a ball. So we're taking coming into the top. It's basically a C shape, and we have a segmented, which is a half of a ball that we are using for a control valve. So this is typically the actuator, like we discussed in the previous slides, for finite control. We're coming in, we're controlling that precision. So segmented valves can typically handle 85 to 90% of most applications, instead of a traditional globe control valve, which can be very costly. So depending on the working pressure and service conditions, because we can only do so much with here, we do have a anti-cap trim that we put in this valve, but it's limited to maximum 400 PSI differential, whereas we can go all the way up to 4,000 PSI, and we can have all kinds of unlimited options into our valve for those types of trims. So segmented is a half a ball, and it's been around for a long time now, and it works extremely well. So it's part of our control valve lineup.
All right, thanks.
You bet. So again, all the examples, we're moving now into the electric actuators. Some of the actuators that you'll see, here's a ValveCon, here's ours, our spring return. The ValveCon's typically a battery backup. They can use either lithium ion or a typical acid battery. And here is the big green machine, RCS. They make the spring return vertical spring. And then this one is actually a supercapacitor. So supercapacitors have come on very strong in the last 4 to 5 years because of there is no battery, there is no and the lithium ion, when it's typically a shelf life or life of about 5 years to 6 years, sometimes longer. But when that lithium ion is exhausted and the battery is no longer able to do its job, that becomes hazardous waste. So you're having to look at a number of things to consider to manifest that off and get rid of it. So there are drawbacks to battery backup. With a spring, so this is basically our rack and pinion actuator underneath the actuator. So we're incorporating two items together here, and it's very reliable. We've had lots and lots of success with this. But we can go a little bit higher than what these guys can do on our spring return, and it's a very, very nice, clean, easy setup. Everything's ISO 5211 mounting, and it makes it easy, as well as the ValveCon. And I believe RCS is moving into the ISO 5211 category after 40 years. This is the one that is very, very interesting, that's come on very, very strong. The supercapacitor, basically there's a bank of capacitors that are in a row that we can cycle on our actuator. This happens to be our actuator, the little orange unit, 3 times that the supercapacitors are holding that electrical charge, and we can operate this safely 3 times before it actually gives up the ghost and it has exhausted the supercapacitors that are inside of them. So they're working on larger units. Currently, we only go up to 1,500 pound. The spring return units, we can go up to 2,200. I believe RCS caps out at 1,850. So these actuators are used in applications where absolute fail-safe is required and a must. We need, sometimes customers will use these as an ESD, dampeners, tunnels, things of that nature where it is a requirement. I'm not so sure about battery backups in some of these dampener applications through the history, but spring return has always been the most proven and reliable. But again, like I said, this technology is coming along very, very nicely. There's nothing to dispose of. There's no hazardous waste, and there's no springs to contend with. So a lot of guys, especially when they go to do maintenance on a unit like this, it intimidates them. So this one's not as intimidating as this one. So understanding how to have maintenance and repairing these safely is an important feature to remember. Electrohydraulic. These actuators are typically used in an oil and gas industry, the large pipeline valves, trunnion, double block and bleed, that require a high torque. Now this one on the bottom right, it happens to be a linear that you could use for a control valve, globe control valve. The other 3 that you're seeing here are electrohydraulic. And the nice thing that is a nice feature about some of these is that you'll see the manual override. You'll see the manual override. So if we lose electricity on trying to make this valve open or close, and they're in the middle of Montana pipeline, and they're trying to open or close this valve, they can simply switch it to the manual mode and pump this and get it to move to the desired location. So you see the handle that's here. But these valves, or actuators, excuse me, are typically used in very, very high torque, and that is their backup system that you're seeing for every one of these is a hydraulic, if I can speak, manual override to force this actuator open or closed. So it's using its electrical actuator as a normal. Then once we lose power, then they have to have the ability to open or close these valves. So typically in these larger pipelines, these are very high torque, very high force output that are used for these type of applications. The multi-turns, you've seen these probably out on even pipelines. So you'll see rotor, you'll see limit torque, you'll see hours. This happens to be a picture of hours out on pipelines and stuff. These are for gate valves, slab gates, globe valves, and even control valves, depending on the connections. And the stem will usually end up, especially for a rising stem valve, and then you have non-rising stem valves. But for the rising stem valves, it will actually go up through the center. So you'll see a lot of these that, I think I have a picture of one here coming up. But it kind of gives you an idea of this turns multiple times and is timed to stop once we get on travel, and time is a essential part of that. So some companies, especially a pipeline, let's say that we have to have this thing open within 30 seconds or a minute and a half, depending on the size of the actuator. That is what we will use these for, to move these larger valves up and down to achieve that. And the multi-turns, they work extremely well. These are typically a higher voltage, 220, is usually where they start. And they do a 380 or 440, and they have all kinds of communications available for these, from field bus, Modbus, Aussie bus, the typical communications that a pipeline company, or maybe you're not a pipeline company and you just want to automate a slab gate. This is exactly what we would use. So they have lots and lots of capabilities and functions available to them. And you can see that all of them have a manual override on them. So that way, in the event of an upset, we just pull the clutch and we start closing or opening, depending on the field position. Here are a few of our automated valves. Here's the picture. I was at a project. I was down in Houston. These are rising stem slab gates, and you'll see these rotork actuators that we put on these. I believe this is a 42-inch valve. So it just kind of gives you a brief overview of what we can do. Linear, rotary. This is our triple offset valve. This is our HVAC and boiler feed water valves, slab gates, quarter turn. So the endless possibilities for automation, like I said in the beginning, is to consider what your requirements are. This actuator happens to have local controls where you can externally turn, open, close the actuator. And again, just about every single one of them, you can even see it here, but they all have manual overrides. That's a must when you are trying to make sure that you need a valve to open. So the electric actuation has come a long way over the last 10 years with the brushless motors that have come out, and the reliability, because we're starting to see more and more in the industry with air being what it is. You're seeing a lot more movement to electricity, as it's a lot easier and cleaner to set up versus a pneumatic system. So, and each one has its own advantages and disadvantages. So looking at these, a lot of customers like the idea of electric, and the improvements that have been made over the last 15 years or so have made it a lot more reliable. So, and that's it for today. So.
All right, thanks, Brian. Lots of great information there. We do have a couple of questions here to cover. Sure. If I could, I'll go through these one by one here.
Sure.
All right, so not sure if this is something that can be exactly answered, but is there some sort of consensus or some way you can comment on what's considered better for controlling purposes, globe valves or ball valves? Is there a way you can answer that?
Typically, what we have done here in-house for J-Flow, typically it's 100 pounds or less that we're trying to control. We will use our ball valve with a V cut into the ball. Okay, so that's picture a ball valve with a V cut into it that we can use on the lower pressure applications. Our segmented valve, if we went back and talked about that, that is typically good for up to 600 ANSI class. We have done 900 ANSI class on our segmented. As you increase in pressure for our control valve applications, depending on the type of turn down that is required, the CVs that are required, and the flow conditions. So to answer that, it's very simple for us. If it's 100 pounds or less and something that we can control fairly easily, we will use a V-ball. If it's something that is above 100 pounds and we have temperatures involved, flow conditions, we can use our segmented valve. If it's something that is required for smaller, tighter control, anti-cavitation trims, a number of things, then we will typically move into a globe control valve that will have much, much higher control and finite control versus the other two valves that I previously mentioned. So to answer that, it is a number of customer comfort, that is something that we can provide seat-wise, material-wise, to handle the application. So there's a number of things to consider when we do that.
Okay, great. I'll let you know if there's any follow-up on that. Another question here. So about midway through, you touched on some of the QA checks that are important and critical to make sure the package is operating properly. Is that something, those QA types of testing, are those generally seen, across industry, or is that something that maybe JFlow has specifically instituted to ensure quality?
I think that a lot of companies have started doing that because the customers are requesting that. So they need some type of validation, verification that whatever piece of equipment it was that was assembled or repaired, whatever the instance might be, is that it was done and verified and checked. I think a lot of companies are starting to incorporate that if they haven't already. But I know that a lot of the larger companies, it is required, like our company.
Perfect. Okay. And then let's see, last one we have in here right now, and I will remind everyone, if you've got something on your mind, please get it in here. We'll be around for another minute or two. So last question here for now is, Fisher control valves, I think, are something that a lot of people are familiar with. Is there some sort of similar package that can be done in an alternative way, in maybe a smaller dimensional package than what we're used to with a large Fisher control type setup?
We have looked at a couple of designs that we were talking about using a very, very small actuator that packs a bigger punch. The biggest issue that you have with globe control valves is having enough thrust force to push that plug back down into the seat for a fail position. So that presents the challenge always within itself. And we've looked at different actuators, but the footprint that is required for an actuator is only enough to close or open and control that valve. So sometimes an actuator that is larger is required. Sometimes an actuator that is smaller can be used. Cylinder actuators a lot of times can take the place of that. In the example of Valtech or one of those kind of companies, and we have those as well. So we look at cylinder actuators, they are more compact and create a lot more thrust force, but typically they require a little bit more air to get that same job done. But we are working on a lot of those where an example, just like I just had spoken about, Dan, was the segmented valve. So the segmented valve takes up very, very little space. It's very compact and it can do just about 90% of most of the control valve applications, with the exception of the high pressure, high steam, and high differential type application. So we are limited in that aspect.
Okay. All right. I'll let you know if there's any follow-up to that, but I think that's all we got for now. So I think, Kevin, maybe you have a little bit to wrap us up here.
Yep. Thanks, Dan. Hey, thanks a lot, Brian. A lot of great information there. And this recording certainly will be out there for anyone to come back to should they wish, when they wish. We at Peerless, you may have seen the screen, we've been involved in quite a few valve projects around the world, some pretty challenging applications and some that aren't so challenging, but we will help with spec review. That is something we offer. And I wanted to point out this segmented ball valve. There was a lot of discussion about that. And you can see in this cutaway, this ball, and Brian, jump in if you wish, but the ball is cut away in that C position that Brian was discussing. So
Yes.
we can follow up with information should anyone want more. So once again, we do have a certificate of completion available. Should you want it, just let us know when you get the email for the survey at the end of this session today. Next week, you may recognize this as a recent session we did, but based on the feedback we got in the emphasis on safety, we were asked to rehash it. So we are going to be conducting another live session next Wednesday for hose systems and assembly, really focus on the safety and best practices. So we hope to see you there next week. Spread the word. We appreciate your attendance. And again, any follow-up questions, just please let us know. We're here to help. Brian, thanks again.
Hey, thank you guys for the time. I appreciate it. I hope some people learned something and at least brought a new perspective to it.
I'm sure that happened because it happened for me. So thanks.
Thanks.
Take care.
All right. Thanks, everyone.